right, today we are doing Chapter 2, Section 2, Polynomial Functions in Pre-Calc. Today's date is today. Our objective is we're going to graph and analyze the behavior of polynomial functions. We're really going to be focusing on analyzing the behavior. Graphing, I would recommend that you use a graphing application like Desmos or a graphing calculator. So we've kind of talked about end behavior before, but I'm going to go over it again, and this is probably not going to be the last time you see something like this. The first graph that you have here, we've got even degrees for this first column, and this is with a positive leading coefficient. So the end behavior here is up, up. A lot of times I'll just show that with an arrow too. Up, up. And if I've got a negative leading coefficient, it's down, down. And there's two examples there. So positive, both sides are going to go up. Negative, both sides are going down, and that's with an even degree. Not sure where my odd degree went to, but if it were an odd degree, let's see if we can make that just a little bit better. Something must have gotten deleted there. So if I've got an odd degree, so that means my exponent is 3, 5, and I've got a positive leading coefficient, my graph is going to be down, up. So down, up. If I've got a negative, sorry about the handwriting, writing with a mouse, leading coefficient, I'm going to have a graph that's going to start up, and I can have some turning points, and it's going to end down. So this would be up, down. Okay, those are ones that you are definitely going to want to have memorized. So here we want to determine the sign of the leading coefficient and the degree of the polynomial. Well, you can find the degree because it's going to be +1 of the turning points. So you add 1, I am struggling with writing, so let's just write that down. That was much easier. So the degree is you're just going to add 1 to the number of turning points. And you might be asking yourselves, gosh, what is a turning point? Well, it's exactly what it sounds like. They happen at a local maximum or minimum, and we've talked about that. So here, I've got 2 turning points. So it is a third degree. My end behavior is down, up. Well, so that makes sense that it's an odd degree. And my leading coefficient here would be positive. So over here on our next example, we want to look at our number of turning points. It's a little harder to see your turning points on this one. There's 1, 2, 3, 4. Those are real minor turning points, but if you notice, you're going from increasing to decreasing to increasing to decreasing. So we've got a 5th degree, and my end behavior is up, down, so I'm going to have a negative leading coefficient. So on this one, they're not giving you the graph, they're just giving you the equation. We want to determine the end behavior of the graph. Well, it's positive, and it is an odd degree. And that's the main things that we're going to be looking at. So we are looking at an end behavior that is down, up, and it's a 3rd degree. They didn't ask for it, but there's going to be 2 turning points. This one, tricky, because it's not written in standard form. We want to look at the term that has the highest. So we've got even and positive. So we are looking at up, up, and there would be 1 turning point. State the number of zeros and the turning point. This sounds hard, but it's super easy. The number of zeros is whatever the degree is. So in this case, 3 zeros. The number of turning points is 1 less than that. So 2 turning points. I'm going to abbreviate that. That's super easy. So here, state the number of zeros, 4. State the number of turning points, 3. Wow, that was a pretty quick lesson today. Hope you enjoyed.